So the next topic will be jog commands. You guys have already set up the motors, so we'll just jump right into this. So a jog command is an online move command that is specific to a motor, not an axis, not a coordinate system, anything like that. It is just a closed loop move command to move a motor to a specific spot or in a specific direction. It's, again, not associated with any coordinate systems, unlike motion programs, which you guys will see probably tomorrow. And it is associated with the currently addressed motor. Technically a jog command is just the J key. Normally it'll be pound motor number J command. So you could issue pound 3 J plus to move motor 3 positively indefinitely. And if you don't issue that pound N, pound whatever motor number, it will just issue the jog command to whatever the motor you last addressed was. The relevant parameters for it are these ones here. There's jog speed, which is going to be the actual velocity, the actual speed the motor is jogging. Jog TA, which controls the acceleration of the move. It typically will be the amount of time you are devoting to accelerating the motor, but you can also just set it to a specific rate. Jog TS is the same thing, but for your S-curve time, which is the jerk, the derivative of acceleration. There's jog offset, which when we get to triggered moves, which is the next section, we'll use that a little bit. And there's prog jog pause, which is a programmable jog position. That one is not very often used, but we'll cover that a little bit here too. You can change these parameters on the fly if you want, so you can change your jog speed, you can change your jog TA, whatever you want, and it will immediately be issued to the PMAC, but it will not affect a jog move that's already been issued. So if you change your jog speed and want that to immediately take effect, you then need to issue another jog command, and it will now jog with whatever the current parameters are when the jog command is issued. So the actual jog commands, these are the most common ones. There's J plus and J minus, which are jogging in the positive and negative direction indefinitely. It just tells the motor to completely run off in that direction at your jog speed, as determined by jog TA, jog TS. There is J slash, which is a jog stop. That one is probably one of the most useful ones, just because it can be used often just to close the loop on a motor. If your amplifier isn't enabled, you want to just enable your amplifier, make sure you don't have any faults. Or if you want to stop the motor in a controlled manner, issuing a J slash will bring the motor to a stop at whatever its position is. Next, there is J equals constant, which will jog the motor out to a specific distance. If you do J equals 500, it will jog the motor from wherever it was to 500 counts. If you issue a home command, it'll rehome the motor, and it'll get you back to 0. If you issue a home Z command, it'll set the current motor position to 0, and then the jog equals command is relative to wherever the motor's 0 position had been in software. J equals equals is the same thing with a twist. It jogs the motor out to a given position, but it then also sets that position to the pre-jog value. If you ever issue a J equals without a value, it will jog your motor out to whatever value you set here. So not extremely often used, but it is another feature. It's basically just a memory. If you want to set a value, you want to be able to jog to that spot easily. If you issue equals equals, and then later you just issue pound 3 J equals, it'll move you back to that spot. And then you have J caret and J colon. Those are incremental jogs. J caret will command an incremental move relative to the motor's actual position, and J colon will issue an incremental jog relative to the motor's commanded position. What that means is, if you issue pound 1 J equals 1,000, you're commanding the motor to go to 1,000 counts. But your motor isn't perfectly tuned, or maybe you're just impatient and don't let it settle. So the actual motor stops at 998 counts. Now, from this point, if you issue J colon 1,000, it will command the motor to go to 2,000 counts, because that's 1,000 plus the 1,000 you're commanding here. If you instead were to issue j caret at that same value of 998, that one will command you to go to 1998 because it looks at the actual position at the time the command was issued, in this case 998, and then increments that by the command of 1,000. So slight difference, but it does matter. You can think of it as a tolerance buildup for those of you guys who do much drafting. It's if you issue the J colon, it will be no tolerance buildup. Each move is defined with respect to your 0. If you're using the J caret, then that is with respect to wherever you had been last, so you can incrementally accrue errors and it may eventually lead to a problem. In addition to those, there are some variable jog commands. These all use the motor x.prog jog pause register. It's just a register. You define it and set it equal to any value you want. Once you have it equal to that value, you can basically use the asterisk character as entering in that value. Whenever PMAX sees j something and then that asterisk, it replaces that asterisk with the value stored in the prog jog pause register. So set motor.prog jog pause equals 500, then you can issue j caret asterisk, and that'll be j caret 500, j colon asterisk, j colon 500. So if you want a programmable jog move, you want to be able to just continuously issue the same jog, say you have it in a loop for whatever reason, you can issue your jog command to use this asterisk character, and then in some other program somewhere, change your prog jog pause register, and when this loop reruns the next time, it will jog you to a different spot based on what you have in your value. So if you guys want, you're welcome to try out these lines of code here. Just download them all into your box one at a time. You should see off the first one, your motor 1 will just jog negatively, won't stop, it'll just continuously jog. These next two lines here, #2 followed by a j/, will close the loop on motor 2. It shouldn't actually move, it should just enable the amplifier and hold position. So if you try and manually move the motor, you'll feel it fight you. Then there's j == 1,000, which will jog you out to 1,000, and then if you move away from 1,000 and then issue a j equals, it'll send you back there. And then the last two lines use the prog jog pause register setting equal 2,500 and moving the motor out there using the j = asterisk command. So I'll give you a second or two if you want to try this.
The speed, what's the units of that? So mine's set at 32, but my speed is more...
It's, well, if you are issuing short moves, you may not actually get up to your jog speed because it may just be pure acceleration or deceleration, but it should be in motor units per millisecond. So if you have a 2,000 count encoder that's saying 32 motor units per millisecond.
Well, I did a continuous jog.
Yes.
My speed is set to 50.
Okay.
My motor units per millisecond is 25.
Is the following error building up at all?
No.
Okay. Let me just double check the SRM then. I want to...
Well, I mean, you don't have to go into depth.
Well, no, but it's a...
It looks like it's about half. So when I set it to 32...
Yeah, it should just be a direct speed in motor units per millisecond. When you set it to 32, what did it go to, 16 or 32-ish? Or
It's staying at 25.
most likely then you have a abort speed, a maximum speed set at 25 that's capping you. So when you try and command over that, PMAC automatically drops it down to 25 and issues that command instead. For safety reasons, as we'll see in a little bit, the abort parameters can override any jog TA, jog TS, or jog speed command, just so that if you know you never want your motor to travel faster than this here, you can set that up and PMAC will hold you to it. Okay, so moving on to the next slide. The actual move, the actual acceleration portion of the move in this case. So when you issue a jog command, in this case, I'm just going to say they issued a J+ command. The first thing that happens is you will have an S-curve time of TS. And I'm assuming all TS, TA values are positive. If they aren't, it looks the same with values a little bit different. But the first thing you'll do is you will begin to increase your acceleration for a duration of TS, motor.jog_TS. Once you reach your actual acceleration that you are going to have for the duration of the move, you'll continue to accelerate, and then in the end, you will lower your acceleration until you level off at your actual commanded jog speed, your actual commanded velocity at this point here. So you have an acceleration, increase in acceleration here, and another change in acceleration up here with a period of constant acceleration in the middle here. The total acceleration time is equal to TS plus TA. This is different from turbo, if any of you guys know that. In turbo, it had been the total acceleration time is TA plus 2 TS. It's been changed now just TA plus TS. So the TA timer, if you will, starts in the middle of the first TS and ends in the middle of the second TS. If all the values are greater than 0, jog TA and jog TS, then this is all it does. You are specifying the amount of time in milliseconds that PMAC will spend accelerating or changing the acceleration. If the values are less than 0, though, if they're negative values, then you are actually commanding the inverse rate. It's a bit of a complicated change, I know, but in turbo it had been you're commanding the time, so to try and keep that consistent, if you're giving a positive value, you're still commanding the time. But now, if you issue a negative value, such as negative 0.25, what you're actually saying is, I want to move at a rate of 4 milliseconds squared per motor unit, or inverse of that, I guess. 4 motor units per millisecond squared is the acceleration. So if you're giving a negative value, that is a rate, or it's an inverse of a rate. And we'll do some examples of those in a second just to see how it looks out. But back to this again. If you have a system such that for whatever reason your TS is actually greater than your TA, so you're saying I want to increase my acceleration for longer than I want to hold that constant acceleration, then your entire move will be S-curve time. You won't have any constant acceleration here. You'll just be curving up like this, and then you'll immediately begin curving down. So can't command something that's physically impossible. The TA is not going to be lengthened, so to speak. Your move acceleration will be just dictated by TS at that point. Okay, so that's the acceleration portion of the move. To look at the entire move, in this case, we're issuing a J+ command followed by a J/ command. I'm going to use the mouse for this rather than walking across the whole thing. The first thing you'll notice is that you issue the J+ command, and there is some slight delay, just move calculation time. The command has to go through the PMAC. That is minimal. I can't tell you the exact value of it. Depends on clock speeds and a bunch of stuff, but it's minimal enough that it can be ignored in most practical applications. As soon as PMAC processes that J+ command, it immediately enters a jog TS period as it enters the S-curve to begin accelerating the motor. After the TS period ends, it will go into constant acceleration here, and then it will S-curve out off to a set velocity. That velocity is going to be equal to A, which is your motor jog speed. So you'll accelerate up until you get your motor jog speed, and then you'll hold velocity even if you could theoretically go faster. It's not going to try and compensate for the fact that the instant you issue the J+, it's not already at the jog speed. It will account for the acceleration, the S-curve time in its jog, and it knows that it's not going to be exactly there, but it's as good as it can get physically possible based off the parameters you entered. It will continue indefinitely with a J+ command until you issue another command that would stop the motor. In this case, we're issuing a J/ command, which is at jog stop, and as soon as we issue that, again, there's a slight calculation time before an S-curve time to decelerate the motor, a constant deceleration period, and then an S-curve time to round it out, ending with a velocity of 0 and a position of the integral of that graph there. So the J/ command immediately begins to stop the motor. It does not back it up to the point where it was when you issued the J/ command. So if you're moving, you will be a little bit beyond it in whichever direction you're moving. but it will bring it to a closed loop stop as quickly as possible, as determined by your jog TA, jog TS. Now, there is one catch to that, which is this here, and this is technically the wrong parameter, but it gets the point across. Your max acceleration and your max S curve are going to be controlled by your abort TS and abort TA. If your abort TS, the amount of time you're saying you need, absolutely need, for the system to come to a controlled safe stop is greater than your jog TS or jog TA, it will slow down and use the abort values instead. Additionally, if you're going with the negative inverse, so you're commanding rates instead of time period, if your abort rate is slower than your commanded rate, it will slow you down to your abort rate, because the whole purpose of the abort is this is the absolute fastest my system can come to a safe controlled stop. So if you find, such as you found there, if you find your motor is not moving at the commanded speeds, it's most likely a matter of the abort parameters are limiting you more than your jog parameters are. Okay. One other thing to note is we have a couple of status bits that can be used for checking motion. In this case, we're looking at the desired velocity 0 status bit. That will go true whenever the desired velocity for that motor is 0. You have the in position status bit, which is the motor in its commanded position, or does it believe it's in its commanded position? And last, you have the move timer active status bit. Whenever you issue a move command that has a defined endpoint, it's not an indefinite move, it will go true. Whenever the motor is not doing a move that has a defined endpoint, it will be false. So we see when you first issue the J+ command, desired velocity and in position true, or in position both go to 0 as we have a desired velocity of our jog speed. We are not in position as we're being commanded to move. And the move timer is active immediately because for the acceleration profile that is a defined profile. Now, once we get to our constant velocity, the move timer active bit goes false. The reason for that being, even though we are still moving, it's an indefinite move. It doesn't know when the move's supposed to end, so the timer stops itself because as far as it's concerned, it has reached the endpoint, which is just jog speed. Now, it continues on in that state with desired velocity 0, in position, and move timer active all false until we issue J/ there. As soon as we issue the J/, move timer active goes true again because we are giving it a defined path to follow, the S curve and the acceleration down to 0. And then at this point, all the way out here, after the motor is finally stopped, our desired velocity 0 bit goes true again because we are trying to be at a velocity of 0. That's what we're commanding. Our in position bit goes true because we've issued a J/ and we are stopped at our current position. And move timer active goes back to 0 as the move has been completed. So if you ever want to set up a PLC or some sort of script to run in the background and watch to see if a jog move is completed, these are 3 of the status bits you can use for that and how they should behave in response to a couple of different jog moves. So now I have some exercises for you guys. I want you all to just try these 4 moves here. This first one here is jogging motor 1 with the following settings. Notice that we are giving a velocity, an acceleration, and a jerk, not motor speed. Well, we're giving motor speed, but not TS or TA. We're giving the rates. The second one, I want you guys to set a pre-jog position and then issue a couple of jogs. The third one, I just want you guys to explore the difference between J equals and J colon. And then the fourth one, I want you guys to use prog jog pause. While you're doing that, I'm going to do some calculations really fast for that first one on the board. And I'm going to erase this. So just to see, you don't have to look up if you already did the math, but for the acceleration and the jerk values, you're going to want to set your TA and TS according to these two here. To get an acceleration of 0.05 motor units per millisecond squared, you're going to set your TA to -20, because the inverse of that is 0.05. And to get a jerk of 0.04 motor units per millisecond cubed, you'll set your jog TS to -25 milliseconds cubed per motor unit. And again, that's because if you set a negative value for TS or TA, it no longer treats that as the number, it treats it as the inverse of the rate that you want to have.